Hi, I'm Rob Tweed, the developer behind the QEWD platform and QEWD.JSdb. And in this third video on QEWD.JSdb, I want to delve deeper into the mapping between JSON and the underlying physical QEWD.JSdb database, and demonstrate the fine-grained control that you have over on-disk objects. I also want to show you that they're every bit as flexible as normal in-memory objects. I'm going to assume that you've watched the first two videos in this series on QEWD.JSdb. If you haven't, I'd recommend that you do so before watching this video, as some of it may not make sense otherwise. I've provided the links to the videos in the comments for this YouTube video. In the previous video, I showed you how you can map a complete JSON document between in-memory and on-disk JavaScript objects. Let's see how that's just scratching the surface of what's possible. If you watched the second video, the following should look familiar. In my browser, I've got the viewer application displaying the persistent on-disk version of the config object that we played around with in the previous video. And meanwhile in the terminal, I've shelled into the QEWD container, started the node.js REPL, and loaded the QEWD.JSdb shell module. Okay, so the first thing I'm going to do is create a new JavaScript object. I've created this particular object because it's fairly small, but it has quite a complex and fairly deep hierarchy. Here's a tidied up view of what it looks like. Now, if you remember in the previous video, you saw that we can define a document node object like this. That would instantiate an object that represents the YOTADB global named config. What I didn't tell you is that you can also specify one or more subscripts when instantiating a document node object. The subscripts you specify don't need to already exist in the physical storage, so I could do this instead. Every document node object has the same properties and methods available for its use. So let's see what happens if I apply the setDocument method to this document node object and map that in-memory object that I just created into it. Okay, so if we look in the viewer's left-hand panel, we can see that it's merged the contents of that in-memory object that I created into this part of the config global, under the JSDB subscript that I specified when I instantiated the document node object. Look how it's added the JSDB subscript and mapped everything else underneath it. The viewer's right-hand panel shows how that newly added chunk of data would map back into the original JSON if we used the getDocument method. And you can see how the structure of the original in-memory OBJ object will be maintained. Now, as we saw in the previous video, the global storage subscripts have a one-to-one correspondence with the JSON keys. So for this quite deep hierarchy, we now have quite a few subscripts. So I could do this, and I can get back our original object contents. But what if I do this instead? What I'm doing with this command is specifying this section of the global storage. So let's see what I get if I invoke its getDocument method. So this is pretty cool. It's just returned the subset of JSON that was defined under the subscripts I specified. And what this means is that QEWD.JSdb allows us to retrieve subsets of the on-disk object, rather than always having to retrieve the whole thing and manipulate sub-objects in memory. So let's try going down one further level. Now I'm dealing with this path in the global storage. And if I do this, and let's look at X, you can see that we've drilled down even further and retrieved an even smaller subset. Okay, so what happens if we go down a further level to one of these leaf nodes? Now I'm using this path. Let's try its getDocument method. So this is interesting. For this node, getDocument returns an empty object, but we know that this node has a value of YOTADB. So what's going on here? Why didn't it retrieve the value? Well, it's time to explore a few of the properties of document node objects. First, we can confirm that our document node object exists as an on-disk object by using its exists property. And as you can see, that returns true, But let's compare that with a document node object that we know doesn't exist in storage. Let's create one. And okay, it's false, as we would expect. Now let's try this property. This tells us that this node doesn't have any child nodes under it. In other words, it's a leaf node. By the way, we can use the path property to see the keys that this node represents. Compare this with the object that we named database. It represents this node. And if we check its hasChildren property, we can see that it does have child nodes. It's an intermediate node, in other words, a non-leaf node. So the rule is that getDocument will only return a populated object for nodes that have children. Now let's try this. So this says that our leaf node has a value, whereas this shows that it doesn't have a value because it's not a leaf node in the JSON hierarchy. Okay, so now let's try this. And there we go. To get the value of a leaf node, you use its value property. Now remember we created that foo node a minute ago. Take a look at what happens if I do this. That's very cool. It's added a new leaf node into our onDisk object. You can see that the value property is a read-write one. So now if I do this, you'll see that I can also directly change the value of an existing onDisk object's leaf node. So this really is fine-grained storage. We can set and get sub-objects at any level, and even set and get leaf node values anywhere in the onDisk object. So to summarize what we've seen so far, to fetch a subset of an onDisk object, we can use getDocument on an intermediate node, while for a leaf node, we can use the value property to fetch its value. To save an object to disk, we can use setDocument on any node, and to set the value of a leaf node, we use a node's value property. So what about deleting from onDisk objects? Yes, we can do that too. We use the document node object's delete method. Let's see it in action. So the foo object represented this leaf node. Let's apply its delete method. And as you'd probably have expected, it's deleted from the global storage. And that means its exists property is now false. How about if we invoke the delete method for an intermediate node? In other words, a non-leaf node. Let's try that database object, which represents this section of the onDisk storage. Okay, so what you see is that not only this node, but its entire subtree of child nodes has been deleted. We should therefore be able to delete the entire object we added at the beginning of this video by invoking the delete method for the object named db. And sure enough, it's deleted from global storage. And if we try and retrieve it, it returns an empty object. Let's check its properties. So it doesn't exist. It doesn't have children. It doesn't have a value. And if we try and retrieve its value, we just get an empty string. So it's definitely gone from storage. So okay, what happens if I now do this? And yep, the entire object is deleted from global storage. So that's a quick look at QEWD.JSdb's onDisk objects, and hopefully you can begin to understand how flexible and powerful they are, and yet how simple they are to work with. You have the same fine-grained level of access that you have with normal in-memory objects. In the next video, I'll look at how you can navigate between document node objects within an onDisk object, adding even more power and flexibility to QEWD.JSdb. So that's it for now. Thanks for watching, and see you in the next video.